Even a perfectly designed algorithm will make mistakes from time to time. And while there might be human oversight to correct some of these mistakes, we aren't perfect either. So, despite our best intentions, things will go wrong. People will object to the decisions that are made using AI. The question is, what do we do with these objections? And to what extent do we facilitate the process of contesting a decision? For there are different alternatives to what one might contest to: the specific information on which the decision was based, the use of an algorithm, the decision itself, perhaps even the data gathering process. How should these kinds of contestability be included in our design? Let's start with the data itself. There can, of course, be problems with this data. It could be outdated or plain wrong. In such cases, there is an in principle easy fix. Allow people to adjust the data such that it correctly reflects them. At the same time, the fix is not quite that simple. While many such changes might be benevolent and improvements on the data, fraud is possible. If you combine easy editing of data with explicit explainability techniques such as counterfactuals, which tell you how the input should change to change the outcome, then allowing people to change their data at will is an easy way for them to get their desired outcome. So, simply allowing users to change their data jeopardizes the data quality. Changes would ideally be verified in one way or another, but even completely accurate data might not be enough. Deliveroo, for example, registered whether or not its employees showed up to their planned shifts, but it didn't include a reason for that absence. Employees got the same treatment whether their absence was due to illness or just plain forgetfulness. Data need not capture the full situation, and so there might be cases where a decision is made incorrectly or unfairly because important features were missed. Users can be given the opportunity to add contextual information, but algorithms cannot readily take this additional data into account. An additional decision procedure would be needed where the extra information can be weighed by people. These additional decision procedures would likewise pop up when we allow decision subjects to contest more than just the data that is registered. If they can object to the decision, arguing that, for example, the algorithm made a mistake, then we cannot just ask the AI itself to revise its decision. A person will need to reevaluate the case if we want this kind of contestability, which might in turn conflict with values such as consistency and fairness, as people sometimes made ad hoc and biased decisions. None of these are reasons to completely reject contestability. Instead, they are motivations to seek out design options that support contestability while maintaining other values. For example, an automated contestability method can consider the decision that is contested by finding alternative decision boundaries and their support level. As you can see on the slide, such a system would first look for the most plausible decision boundary where the desired outcome is realized, in this case in image B. Then it can consider counter-arguments in the form of decision boundaries which maintain the current decision, in image C. By comparing the support of the decision boundaries, that is, looking at how consistent they are with earlier decisions, one can offer the option to contest decisions while maintaining consistency. Although this doesn't allow for the option that a larger group was misclassified, as consistency with earlier decisions is used, it shows that the contestation is also something that can be designed for. It may not be a direct part of the algorithm that is developed, but it is still a vital part of the broader system in which the algorithm is deployed. How we design contestability, what we allow to be contested, and in what ways, will have a serious impact and should not be ignored. Here too, automated systems can help, but it is precisely the possibility that such systems can fail that needs to be controlled. What happens then is a question we shouldn't forget during our design process.